So welcome everybody to our second example in our discussion of power series. So if we're given a power series and we're asked to find the interval of convergence, what we would turn to is the ratio test. So let's review what the ratio test says. So for the ratio test, we're given an infinite series, and we want to look at the limit as n goes off to infinity of the absolute value of the n plus first term over the nth term. And that's going to give us some value rho. Now, in the case when rho is in between 0 and 1, we know that the series is going to converge absolutely. If rho is bigger than 1, we know the series will diverge. And when rho is 1, then we have an inconclusive test. And so we need to turn to some other test at that point to determine convergence or divergence. And so where would we begin with this one is looking at the limit. So we look at the limit as n goes off to infinity of the absolute value of a sub n plus 1 over a sub n, which in this case, being our infinite series, this thing is going to look like an n plus 1 squared, x to the n plus 1 over 2 to the n plus 1, times now the reciprocal of our nth term, which is going to look like 2 to the n over n squared x to the n. So simplifying this algebraically, what we end up with is the limit as n goes off to infinity. So what happens, our 2 to the n's are going to cancel out in that case. Our x to the n's are also going to cancel out in that case. And so we have, on top, we have an n plus 1 squared. On the bottom, we have an n squared. We have a 2 in the denominator, and then we've got an x in the numerator. And so if we kind of take out all of the terms that don't depend on x, we have, or don't depend on n, we have the absolute value of x over 2 times our limit as n goes off to infinity of n plus 1 over n squared. And so what happens in that case, as n goes off to infinity, n plus 1 over n is going to approach 1, and so this limit is going to be 1, so we get a value of x over 2. Now, according to the ratio test, this is going to converge, or absolute value, rather, sorry about that. The absolute value of x is going to be over 2. It is going to converge when this is less than 1. Okay, so what this in turn gives us is an interval where we have the absolute value of x is less than 2. And so for this one, we know that our radius of convergence is going to be 2, and the center of our power series is x equal to 0. So what this gives us now is kind of a value for, gives us an idea, but the couple of points that we don't know about is what happens at the endpoint of our interval. So what we have in our kind of real number line, we've got a value of 0, we can go out to 2, and we can go out to negative 2. So right now we know all of our values in between negative 2 and 2 will work. That will give us values for there. But if x is equal to 2, or x is equal to negative 2, then remember what happened. This gave us a negative 2 over 2, or a 2 over 2 gave us a value of 1, and so this was where our ratio test was inconclusive. And so when we actually have those values, now we need to test those points individually with some other test to determine whether we will have convergence or divergence. So we know we have everything in between, but we have to test the endpoints. So test the endpoints individually. Okay, so let's do that and let's see what happens. So if we first try x being 2, let's see what happens when we plug that into our power series. Well, we've got n going from 1 to infinity, n squared of 2 to the n power over 2 to the n power. And so what happens there are 2 to the n's cancel out, and so really we just have a power series that looks like 1 up to infinity of n squared. Well, using the divergence test, we know that since that limit as n goes off to infinity of n squared is going to be infinity, that tells us that by the divergence test, that series is going to diverge. So then we can come back and do the same thing with x equal to -2. So if x is going to be -2, what happens when we substitute into that power series? Well, we've got 1 up to infinity of n squared -2 to the n power over 2 to the n power. So in this case, what happens is that now n equal 1 up to infinity, we've got something that looks like n squared and -2 over 2 to the n power, or we've got a series of -1 to the n times n squared. Well, once again, using the divergence test, if we look at the limit as n goes off to infinity of -1 to the n squared, for our even terms, they will head off to infinity. For our odd terms, they're going to head off to -infinity, and so our limit does not exist in this case. And so this diverges by the divergence test. And so at the endpoints, we know we don't get any type of convergence whatsoever, and so we're left with our interval of. So on our real number line, we had 0, we had 2, we had -2, and we know by our divergence test that our series is going to diverge at the endpoints, but we have absolute convergence for everything in the middle, and so our actual interval of convergence is just our interval -2 to 2. So I hope this has been an informative walk through finding the interval of convergence for a power series. We'll use the ratio test to determine the interval itself, and then we have to come back and test the endpoints of the interval individually, because that's where our ratio test is inconclusive. So that's kind of our general guide for doing this, and I will see you guys next time.